Hello and welcome to this platform. In today's lesson, I will be facilitating and my name is Shahadu Abdul Fawaz. This platform was created for us to discuss certain topics in core mathematics or in mathematics as we are preparing for our final year exams in mathematics. So far as WASI is concerned, there are certain key topics I would like us to discuss. And first of all, I would like us to discuss the foundational topics. We might have gone through them already, but I would like us to revise them. The key in getting a good grade in mathematics is not knowing sometimes, but revising. So I would like us to revise some of the key foundational topics. And we will start with SAS. At the end of this particular lesson, we will be able to know what a SAD is and also give examples of SADs. We will be able to know and understand some rules when manipulating SADs. We will be able to simplify SADs to their basic forms. And finally, we will be able to perform operations such as addition, subtraction, and multiplication on SADs. When you hear SADs, what comes to mind? I hope we can still remember our real number system where we learnt about rational and irrational numbers. We said earlier, or we learned a real number system that when numbers can be expressed as common fractions of any two integers, such as m over n of any two integers, where n is not equal to 0, these are called rational numbers. And those which cannot be expressed as common fractions are irrational numbers. When irrational numbers now involve roots, we call them SARs. The roots can be square root, cube root, or fourth root. To simply put, we can say that if a positive number is not a perfect square, then a square root is a SAR. We all know what a perfect square is. When we say a perfect square, when you take the square root of a particular number and it gives you a positive number, whole number, then that number becomes a perfect square. For example, 4. 4 is a perfect square because square root of 4 gives us 2. So when you take the square root of a particular number and you don't get a positive whole number, then it becomes a SAD. And generally, the form and parts of a SAD can be nth root of a, where the n represents the index or the exponent or the power. The square root becomes our radical sign, and the term under the square root becomes the radicand. So, for example, we can have square root of 2, can have cube root of 5, can have fourth root of 8, you can have fifth root of 18, to mention but a few, some examples of SARS. Now let's consider some rules when manipulating SARS. The first one we'll be talking about will be when you have square a root of b plus c root of b, this will be equal to a plus c, that is root of b. That is, we add the outside terms, then because we have the same term or radicand under the square root signs, we pick just one and we add the outside term. This is what we call the addition law of SARS. But you should make sure that they have the same radicand. For example, if you have 5 root of 3 plus 2 root of 3, they have the same radicand under the square root. So just pick root of 3, then add 5 and 2, which gives us 7 root of 3. Then the second rule is if we have a root of b minus c root of b, this is also equal to a minus c root of b. And this is the subtraction law of SARS. The same thing applies here. You should make sure that we have the same radicand. Then you just subtract the outside terms. So example, if we have 8 root of 5 minus 4 root of 5, this will now be 8 minus 4 root of 5. That gives us 4 root of 5 when you simplify. Then the third rule will have a root of ab can be expressed as root of a by root of b. And that gives us the product of the number or the radicand, square root of the product of the radicand here. So we can easily say that when you have square root of a product, then the is the same as the product of the square roots. That is, when you have a certain number, look for two numbers which are factors of that particular number. Multiply square root of the factors. That will give you back a SAD. Example, root of 15 will be the same as root of 3 by 5. And we can separate them as root of 3 multiplied by root of 5. Then for the fourth rule, we have root of a root of b, rather, multiplied by c root of g. And this will be equal to ac by bd. We multiply outside terms, then multiply inside terms. So multiply 3 by 4, then we'll multiply 5 by 2. That gives us 12 root of 10. Still with rules when manipulating SARS. Let's look at rule 5, where we have square root of a over b. This will be the same as square root of a over square root of b. I mean, you can take square root of a, the numerator, over square root of b, the denominator. For example, we have square root of 2 over 3. It's same as square root of 2 over square root of 3. Or, when we have square root of 25 over 16, it's same as square root of 25 over square root of 16. And we can simplify this one as 5 over 4. Since square root of 25 is 5 and square root of 16 is 4. Then for rule 6, when we have a root of b divided by c root of d, it's same as dividing the outside terms and dividing the inside terms to get a divided by c, root of b over d. Example, 4 root of 5 divided by 3 root of 2 gives us 4 over 3 root of 5 over 2. Then for rule 7, when you have square root of a squared, is same as square root of a squared, and this gives us a, because this square goes with the square root, leaving a. Example, square root of 7 squared is equal to square root of 7 squared, and this will go with that, leaving 7. So whenever you have square root of a certain number squared, it gives you the same number, or it gives you the radicand. For rule 8, it's related to the rule number 7. When you have square root of a to exponent n, is the same as square root of a exponent n. For example, square root of 2 exponent 3 is equal to square root of 2 exponent 3, which is equal to square root of 8, because 2 exponent 3 will be equal to 8. Then you can now simplify this one. We can have rule 9, where we have a exponent negative n under a square root, and this will be equal to 1 over square root of a exponent m. The m here was negative. When you come here, it changes to positive. You reciprocate it so that we'll now have 1 over root of a to exponent m. Because we are changing the exponent to positive, you have to divide by 1. For example, if we have square root of 3 exponent negative 2, then this can be equal to 1 over 3 exponent 2, which is equal to 1 over root of 3. Square gives us 9. Then this is equal to 1 over 3, because root of 9 is what? 3. Then for the 10th and final rule, when you have 1 over a exponent negative m is same as square root of a exponent m. For example, 1 over square root of 5 exponent negative 2 will be equal to square root of 5 squared, which is equal to square root of 25, and that will give us 5. So when you are dividing square root of a number raised to a negative exponent, it is equal to that particular number. Then you change the exponent to be positive, but this time around it will be the square root of the radicand. Then you have a positive exponent, just as shown in this particular example. Let's now simplify SAS. Example, if you are asked to simplify root of 8, root of 18, root of 75, and root of 0.25, how do we do that? Let's look at the answers. For root of 8, we have to look for 2 factors of 8, the radicand. Said that 1 is a perfect square, and we know what a perfect square is. When you look for the factors of 8, they will be 4 and 2, and we can see that 4 here is our perfect square. Then from one of the rules said when you have a product of the factors under the square root, we can separate them as square root of 4 by square root of 2. And we know square root of 4 gives us 2 because 4 is a perfect square. So 2 will then be multiplied by root of 2, and that gives us 2 root of 2. So root of 8 will be simplified as 2 root of 2. Then for square root of 18, the perfect square we can find 18 will be 9. So 9 by what gives us 18? Let's say 9 by 2. And we can also separate these as square root of 9 by square root of 2. And square root of 9 gives us 3. So 3 by 2, root of 2 rather, gives us 3 root of 2. Then for example 3, we have square root of 35 as 75. Square root of 75. What perfect square can you find in 75? When you check through, you see that the perfect square here we can find will be 25. 25 by what gives us 75? Then you realize that 25 by 3 gives us 75. So this can be simplified as square root of 25 by 3. And this can be separated as square root of 25 by square root of 3, which is equal to 5 root of 3, because square root of 25 will give us 5. Then for the last and final example 4, we have square root of 0.25. First of all, we can see that it is a decimal fraction. The radicand is a decimal fraction. Convert it to a common fraction. And converting it to a common fraction, we have square root of 25 over 100, 0.25. When you take the whole number 25, which is on top, divided by 1, how many decimal points or places do we have after the decimal point? We have 1, 2, and we'll add our 2 zeros. That gives us 25 over 100, then square root of that. Then when you have from one of the rules, square root of a fraction is same as square root of the numerator over square root of the denominator. So this can be simplified as square root of 25 over square root of 100. And we know that square root of 25 is equal to 5, and square root of 100 will be equal to 10. But we simplify it to 1 over 2. 5 into itself, 1. 10 into 10, 2. So square root of 0.25 will be 1 over 2, or say 0.5. Let us now look at addition and subtraction of SARS. We are going to start this with examples. When you have this, you are asked to simplify. How do we simplify? First of all, for addition and subtraction of stars, in order to add or subtract, we looked at that among the rules when manipulating stars. You have to first of all make sure that the radicands are the same. If the radicands are not the same, we cannot add or subtract. Then secondly, you have to look at the radicand. If they are not the same under the square roots, you have to look at them to see whether they can be simplified. If they can be simplified, then you simplify to see whether they will have the same radicand before you can add or subtract. So let's look at the first example. When we have square root, fifth root of 8 plus 2 root of 18, we can see that square root, under this root we have 8, under this we have 18. They are not the same, so we can't add right away. We have to check to see whether they can be simplified. So you can see that 8 and 18 can be simplified. The perfect square we can find 8 will be 4. So square root of fifth root of 8 can be written as fifth root of 4 by 2 plus 18 can be written as 9 by 2. So this 2 root of 18 becomes 2 root of 9 by 2. And we can simplify. We can simplify this as square root of 4 by square root of 2. And we know square root of 4 is what? 2. So we'll now have the 2 multiplied by this. Then in this case, square root of 9 will be 3. We'll multiply 3 by the 2 here. So this then gives us 5 multiplied by 2 root of 2 plus 2 multiplied by 3 root of 2. Then 5 times 2 gives us 10. 2 by 3 gives us 6. So this will be equal to 10 root of 2 plus 6 root of 2, which are simplified. Now you can see that they have the same radicand. So we can now add. Adding, we only add outside terms that will pick one of the square roots. So have 10 plus 6 root of 2. That gives us 16 root of 2 as the solution to example 1. Then for example 2, we have square root of 27 minus square root of 12. We can subtract right away because the radicands are not the same. So we check to see whether we can simplify. We can find perfect square in 27, another perfect square in 12, so we can simplify. When we have to simplify, square root of 9 by 3 will be the same as square root of 27. Square root of 4 by 3 will be the same as square root of 12. Square root of 9, this can be separated as square root of 9 by square root of 3, and square root of 9 is 3. This can also be separated as square root of 4 by square root of 3, and square root of 4 is what? 2. So this will be simplified as 3 by root of 3 minus 2 by root of 2. And this gives us 3 root of 3 minus 2 root of 3. They now have the same radicand. So just subtract the outside terms. So we'll have 3 minus 2 root of 3. That gives us root of 3. 3 minus 2 is 1. And we don't write 1 root of 3. Just write root of 3. For example 3, we have square root 3 root of 24 minus 5th root of 54 plus root of 6. This will be equal to 3 root of 4 by 6 minus 9 root of 9 by 6 plus 6. You look at the least radicand. Is the least radicand a factor of the biggest or the bigger radicals? So when you look at that, you can easily find your factors. So 54 divided by 6 gives us 9. And 9 is a perfect square. That is 9 by 6 gives us 54. Then 24 divided by 6 gives us 4. And 4 is a perfect square. So 24 will be written as 4 by 6. And we can simplify. This is the same as square root of 4 by square root of 6. And no square root of 4 is 2. So multiply by the 3. Then square root of 9 is 3. Then we'll have root of 6. So when we simplify this, it gives us 3 multiplied by 2, root 6. And this gives us 3 root of 6 plus root of 6. This will then be equal to 6 root of 6 minus 3 root of 6 plus root of 6. We can see that they all have the same radicand. So we can perform the operations here. This will then be 6 minus 3 plus 1 root of 6. And that gives us 4 root of 6. Then for example 4, we have root of 50 plus root of 32 minus root of 8. you can see that they can all be simplified. So the perfect square we can find in 50 will be 25. The perfect square you can find in 32 will be 16. And the perfect square you can find in 8 will be 4. So they can be simplified as square root of 25 by 2 plus square root of 16 times 2 minus square root of 4 times 2. And this will be equal to square root of 25 when you separate them, times root of 2 plus square root of 16 by root of 2 minus square root of 4 by root of 2. This will then be equal to 5 times root of 2, 4 times root of 2, and minus 2 times root of 2. Combining or multiplying, we have 5 root 2 plus 4 root 2 minus 2 root 2. We have the same radicand. So we combine the outside terms. We combine them as 5 plus 4 minus 2. And we have root of 2. And this gives us 7 root of 2. We have 5 root 3x power 3 plus 2 root 27x. When you look at this and that, they do not have the same radicand, or the radicands are not the same. We have to first of all make sure that they are the same. But in this case, we have to look for factors which are common to these terms or these radicands. And when you check properly, see that we have 3, 3, have x, x. So the common factor here will be 3x. So we are going to simplify such that the radicand will be 3x. So the bracket here will now be, or this will now be equal to the 5 root of x squared multiplied by root of 3x. Or multiply this and that, it will give us back 3x power 3 or exponent 3 plus 2 multiplied by root of 9 by 3x. 9 by 3x gives us back 27x. To simplify, this will go with that. Root of 9 we know is 3, so this can be simplified as 5 root multiplied by x. So when this cancels, that will be left with x by root of 3. X will give us x root 3x plus root of 9 will be 3. So this gives us 2, 3 root of 3x. Expanding, we have 5x root of 3 plus 2 by 3 gives us 6. So we have 6 root of 3x. We can now see that the radicands or the radicand are the same. The radicand here and here are the same. So we pick one and combine the outside terms. This combined with that gives us 5x plus 6, and we have root of 3. For example 6, we have a root of 27 minus 2 root of 3a squared. The radicands are not the same here too, so we have to make sure that they are the same. And here we look for common factors again. When we look at 27 3a squared, the common factor here would have been 3. So we simplify this as a root multiplied by root of 9 by root of 3 minus 2 root of a squared by root of 3. Root of 9 is a 3. Root of a squared, the square will just go with the square root sign. So this will be simplified as a root 3 by root of 3 minus 2a by root of 3. So when we expand the brackets, we'll have 3 by a multiplying by that, so I have 3a root 3, 2 by a by this, so I have 2a root of 3. Then 3a minus 2a gives us this root of 3. Then 3a minus 2a gives us a. So have a root of 3. Let's now look at how to multiply SARS. And we'll look at that with examples. For example, when we are asked to simplify the following here, SARS here, to simplify this, let's take the first one. We have root of 3 root of 5 multiplied by 4 root of 2. For multiplication of SARS, the radicand doesn't matter, or the radicands doesn't matter whether they are the same or not. In multiplying SARS, we only multiply outside terms by outside terms, then inside by inside terms. So this will be the same as 3 multiplied by 4, and the radicands 5 multiplied by 2. So this will give us 12 root of 10. Then for example 2, we have root of 5 plus 3 multiplied by root of 5 minus 2. This will be equal to, we have to expand. Pick the first term in the first bracket, multiply by the second bracket. That is what we have here. Then pick the second term in the first bracket, multiply by the second bracket. That is what we have here. So pick this, multiply by this. After that, pick this, multiply by this. So have root of 5 by root of 5, root of 5 by negative 2, plus 3 by root of 5, 3 by negative 2, and this gives us root of 25. So root of 5 by root of 5 gives us root of 25. Root of 5 by negative 2 gives us negative or minus 2 root of 5, plus 3 by root 5 gives us 3 root 5. 3 by negative 2 gives us minus 6. And we can simplify square root of 25 as 5 minus 2 root 5 plus 3 root 5 minus 6. Grouping our like terms, we'll have this and that, so have 5 minus 6 plus we have 3 root of 5 minus 2 root of 5. So when we group them, we'll have 3 minus 2, and that gives us 3 minus 2 root of 5. Or you can say negative 2 or minus 2 plus 3. They are the same here. And this will then give us negative 1 plus, here will give us 1. So by root 5 will be the same as root 5. So root of 5 plus 3 multiplied by root of 5 minus 2 will be negative 1 plus root of 5. 5. For the third example, we have root of 2 minus 3 all squared. When we have a certain term squared, it means we should multiply that term by itself. So we are going to expand this as root of 2 minus 3 multiplied by root of 2 minus 3. And just as we applied in the second example, we are going to pick each term in the first bracket multiplied by the second bracket. So pick root 2 multiplied by the second bracket. After that, we'll pick negative 3 multiplied by the second bracket. And this gives us root of 2 by root of 2 minus 3 minus 3 by root of 2 minus 3. Root of 2 by root of 2 gives us root of 4. Root of 2 by negative 3 gives us minus 3 root of 2. Then come to this one. Negative 3 by root 2 gives us negative 3 root 2. Negative 3 by negative 3 gives us positive 9. Simplify. Root of 4 is same as 2. Then grouping like terms, we have 2 plus 9 here. Negative or minus 3 root 2 minus 3 root 2. One will simplify. 2 plus 9. That gives us 11. Then negative 3, negative 3. So minus 3 minus 3 gives us minus 6. And have root of 2. See that we are applying the subtraction of SARS here because they have the same radical. So just pick one, then you combine the outside term. So have negative 3, negative 3. That gives us negative 6. So square root of 2 minus 3 all squared will be 11 minus 6 root of 2. Then for the fourth example, we have square root of 3 plus 4 and square root of 3 minus 4. When we are expanding this will be equal to square root of 3 multiplied by square root of 3 minus 4 plus 4 multiplied by square root of 3 minus 4. Then we can expand this as square root of 3 by square root of 3 gives us square root of 9. This square root of 3 by negative 4 gives us minus 4 root 3 plus 4 by root 3 gives us 4 root of 3. 4 by negative 4 gives us negative 16 or minus 16. So simplify. Square root of 9 gives us 3. Then we'll have 3 minus 4 root of 3 plus 4 root of 3 minus 16. When we simplify, we can see that the middle terms are the same but opposite signs. The terms are the same but opposite signs. This is negative, this is positive. And negative, positive gives us 0 if they are the same. So this will be left with negative 13 because we have 3, we'll be left with 3 minus 16. And 3 minus 16 will give us negative 13. Let's look at the final example. For example 5, we have root of 7 multiplied by 3 root of 7 plus 6 over root of 7. We have to expand this. And in expanding, we have root of 7 by root of 7. Just like we said that when we are multiplying, we multiply inside terms and multiply outside terms. So this one will be equal to 3 by root of 7 squared. So 3 by 1, 3. Root 7 by root 7, root 7 squared, plus this will be multiplied by that. So we'll have root of 7 by 6 over root of 7. Simplifying, 2 will go with the square root here, leaving 7. Then this and that, you can see that they are the same. So this will cancel that. So we'll be left with 3 by 7 plus the top here, 6. And 3 by 7 gives us 21 plus 6. And 21 plus 6 will give us 27. Thank you very much for watching, and please go through the lesson from the start to the end and take notes. Also jot down your questions and then forward it to the platform administrators, if any, to be addressed. Thank you very much. And the next video, we will be looking at how to rationalize SAS. Thank you and bye for now.